All right, so these are the 3.2 solutions. Graphing, I've asked that you please graph using the x-intercept and the y-intercept. I know that a lot of people do know y equals mx plus b form, and that's coming soon, but for right now we're practicing finding our intercepts. So number 17, if I want to start with my x-intercept, I know that my y value is 0, so I substitute in my y value, solve for x, and please don't forget to write these as ordered pairs. For my y-intercept, I know that x is 0. I substitute that value in and solve. Now, for your y-intercept, if you want to use the decimal, that's fine because it terminates. For your x-intercept, please leave it as 7/3 since it's a repeating decimal. And then, of course, we're able to graph with my x-intercept, my y-intercept, and I connect my 2 points. Similar number 18, for my x-intercept, my y value is 0. For my y-intercept, my x value is 0. I solve. Getting my x-intercept is 3. My y-intercept is 9/2. Again, you could write the decimal for that since it terminates. And then I'm able to graph my y-intercept 0, 9/2, my x-intercept 3, 0, connect my 2 points, and I have my line. Number 19 is in y equals mx plus b form, so I know that some people would be able to graph this pretty quickly, but I am asking that you take the time to solve your equation and find that x and y intercept. It looks like I think I've made a careless mistake somewhere, but let's take a look. So for my x-intercept, I substitute in y as 0. I had to add 2 to both sides, and then to get rid of the 1/2, I'm going to multiply by 2, and I end up with 4, 0. For my x-intercept, my y-intercept, I know x is 0, and I'm quickly able, after substituting in, to get right to my y-intercept. So I graph my y-intercept 0, -2, my x-intercept 4, 0, and I've got my line. And so for number 20, similarly, x-intercept means y is 0, so I substitute in and solve. Again, to get rid of this fraction, I want to multiply both sides by 3, finding my x-intercept to be 3, 0. My y-intercept, I substitute in 0. 0 divided by 3 is just 0, so I know that my y-intercept is 1. And so from there, I graph my y-intercept, 0, 1, my x-intercept, 3, 0, and I've got my line. Excuse me. Now, 23 and 24 ask us to take a look about what we would know about a line, basically that any point would have to satisfy the equation of the line. In this case, though, the equation's been written with a k value that we need to solve for. So I substitute in my x value for x, so I get 3 times 2. My y value is 1, so I got k times 1. Simplify, 6 plus k equals 8. Subtract 6, and I know that k would equal 2. If we had been asked to rewrite the equation of the line, we would have even taken the time to go back and rewrite it as 3x plus 2y equals 8. But since all the instructions said was to solve for k, we would be done here. Very similar to number 24 and number 25, I substitute in my x value for my x, my y value for my y. The only difference is that we see 2 k values, so after I take care of my multiplication, I've got to combine some like terms. So 2k plus k gets me 3k. I've added 6 to both sides. And then to isolate the k, I'll divide by 3, and I find my k value is 2. 25, very similar again. There's multiple k values. Both x and y are 2, so I substitute them in. I would recommend distributing the 2 to the k plus 1. I combine my 2 like terms of 2k. I subtract 2 from both sides. So 4k equals 0, divide by 4, and I find that k equals 0. 26 is a little interesting. It asks us to take the time to substitute in k for x and then solve. So you'll notice I substituted my k value for x, -2 for y. I decided to subtract 3k from both sides, divide by my -2 on both sides, and I find k is 2. Now 27 is definitely a little challenging without graph paper, since it's hard to necessarily get your lines to be perfectly straight, but the problem asks us to go ahead and solve or find when these two graphs intersect and then plug the point back into the equations to check it out. So for 2x plus 5y, I worked in black. I found my x-intercept since my x-intercept ended up being my y-intercept as well, for my next value, I went ahead and substituted in x equals 5 and solved for y that way, getting 5, negative 2. I used the other equation, which conveniently did have a separate x and y-intercept, so I found my x-intercept, I found my y-intercept. Now again, it's kind of tough to see where it looks like these 2 points intersect without using graph paper, but to me it looked like they intersected at 5, negative 2. I'm going to know that they intersect at this point because if I plug 5, negative 2 into the first equation, I get 10 minus 10, which checks out. If I substitute into the second equation, I get 10 minus 2, which equals 8, which checks out, and so I know that I have their intersection. All right, there is a better way to solve systems of equations. I think some of you have seen it in the past, but we'll take a look when we get there. Have a good day. Hope this helps.